This is Karen O'Brien, and today I am going to walk you through, well, I'm not going to do the setup, but we're going to walk you through the configuration of pumps with Flow2D. I have set up uh, 4 pumps in this model, and 2 of the pumps have a good configuration, so the water is going to flow through them as it's designed. And then 2 of them have a bad configuration because they were set up incorrectly, or they just don't work for that specific configuration, and you're going to see kind of why. Now, I'm not going to walk you through the setup of these because that's time consuming and tedious. So instead, what I'm going to do is I'm going to show you that if you want to do this on your own, or if you want those full step-by-step instructions, that is in a tutorial. And we're going to use this tutorial to show us a little bit of information, but we're also going to just skip doing the work. Okay, so let's start with the configuration. First of all, let me turn off a bunch of these. Let's start with the configuration of the simple storm drains, and they are set up using hydraulic structure. So in this system, I have a single structure, two hydraulic structures that define pumps. And you can see, actually, the whole system has 4 hydraulic structures. You can see we have this one down here that we're going to use to determine whether or not the water is moving downstream. And this one up here that's going to allow a discharge, a steady state 6 CFS flow through the system. And then the pumps are going to, as this basin fills from these inlet nodes, as the basin fills, the pumps are going to turn on, and then in addition to that 6 CFS, we're going to start to see flow through these pumps and then down to the outfall. I'm sorry, to the outflow condition, the boundary condition. So let's start with simple pump number 1, which is the incorrectly configured pump. Now, when you are working through the tutorial, it's going to show you how to set up the pump in the correct configuration, but the bottom line is the only thing that's wrong about this pump is that it uses a 0 reference elevation for the headwater. Okay, so some things about this pump. First of all, you name it. It is floodplain to floodplain. Why is it not floodplain to channel? Because this is not configured as a 1D Flow2D channel. It's just configured with the grid elevation as a 2D with a dropped grid elevation to represent the channel. So that's why that's floodplain to floodplain. It uses a rating table, and you can see this is your rating table curve, and it's just going to step up. It's going to turn on at 1 foot. It's going to turn on, and then you just need enough discharge or enough of a high depth so that the water in the basin does not exceed the depth. So I doubled the depth that the basin could have. So the basin could be around 18 feet. I just doubled that up to 30. It needs to have a no tailwater effect, and this is configured incorrectly, and so we'll show you the one that is configured correctly next. So if I switch this over to simple pump 2, the only difference, well, actually the rating table is a little bit different, and the head reference elevation is set at the inlet node. So I just get the grid elevation right here, and I set that as the head reference elevation, or the reference elevation for head water, okay? Now, the reason why that's important is because the flow, if you don't turn that to on, then the water, the head for the system will be based on the highest of the 2 nodes. So, and you'll see that when we look at the results. And the table looks a little bit different. So in this one, I did a little bit different. I set this at, I went from 0 to 0.9, and I have 0 flow through the table. And then I went from 1 to 30 and 10 CFS. And I was actually surprised that I thought I might have to set that to 10.1, but I didn't. That actually worked. This table works just fine. Next is, the next thing is the storm drain system. Okay, so this is the correctly configured pump. This is the incorrectly configured pump. And I think that this is incorrectly configured because it's just a pump connecting an inlet directly to an outfall. And I don't think that's allowed in And I think that's not, I don't think that's a Flow 2D thing. I think that's an INP. That's a EPA swim thing. But I don't honestly know for sure. Maybe it is a Flow 2D thing, but I do know that it's not. There's no discharge working through this system. Now, so let's take a look at this. If we go back to our training document, you can see that I have given like it identified the elevations and important information from the project, and I've looked up online some specifications for different kinds of this is a pre-treatment unit. It's a storage unit that will take the floating material and the heavy material out of the water flow. And then this is the wet well for the pump. And then we're actually pumping it up to a lift station, which we're going to call this an outlet node. And it'll basically be lifting it up, and then that will be flowing down to our outfall. So there's a key to this. This cannot be an inverted, like this elevation of this last conduit cannot be inverted. So this isn't perfect. You can see that it doesn't make any sense, and that's why it has these dumb things like this. But it doesn't make any sense because ChatGPT made it. And so like the elevations and things are correct, and like the shut off and turn on and shut off depths and everything are correct, but the profile looks bad. So what I did instead is I gave ChatGPT a profile, and I asked it to make me a new picture that didn't have any of these components, and then I asked it to feed me some nice little cartoon-like graphics of the system, and then I just put those onto the image and tried to stretch them in a way that kind of got them closer to those invert elevations. So so this document helps you, or sorry, excuse me, this graphic helps you understand like the offsets for your conduits and the invert elevations and rim elevations for your conduits. I mean, sorry, for your nodes. And so I was using this to define the storm drain system for this pump. So the way that works is, or the way that you do this is, you'll start by just building the whole thing. So as you can see in the document, I create outfall, create the inlet node and the junction, create the two storage units, create the conduits that connect everything, and then create the pump, which is just linking from the storage unit to this. You can't really see it in the graphic, but this is like an outlet node, and then that outlet node feeds down to the thing. I should have probably put that up here in the conduit, made that look a little better. But anyway, that's how this system works. So you'll create all these features, and then you'll configure the attributes. So to create a pump feature, it's really very, very simple. You'll just do something like you'll come in here and you'll edit, and then you'll add, and then you'll click wherever you want that particular feature to be, and then you'll save. And it's very easy to set these up. I'm just going to turn it off. I don't want to save that. I just want to show you how simple that is. And then for a conduit, if you're doing a conduit or a pump, if you're doing a link, you want to do, you'll turn this on, or you'll select it, and you'll turn on snapping, and you'll turn off the grid, and then because you need to snap, so edit, add, and you need to snap between points. So that'll be left click, right click, and that would finish that, and then save it. But I'm gonna escape out of that, and I'm gonna cancel those edits, okay? Because this isn't about how to set up these features, it's about how they're configured. Oh, this guy actually is still there, so hang on a sec. Let me delete that guy. I didn't mean for that to be there. And then I think I accidentally hit save instead of discard. It changes. All right, so we can get back in here. Let's go ahead and just review these storm drain pumps, and then we'll take a look at the results. So to do that, we need the Flow 2D info tool, and we'll come up here and we'll grab our, whoops, make sure I'm actually on that. Yep, that was the problem. And we'll start with our basin inlet and see attributes. So you can see iBasin in, it is an inlet. It does not have external flow. It does have an invert elevation, which gives it about a 4-foot drop box. So the maximum depth of 4 feet. And so I need that basin elevation, which we know is 1215, and then drop that down 4 feet and give it a depth. Now, for the inlet type, it is a type 3, which makes it a grate. And it's way oversized, but because it only allows 10 CFS, so it's way oversized. And that's probably okay if you're just going to filling up this wet well. That's probably okay as long as that's sealed, and it can't possibly go above the head of the system. Everything is fine. But in reality, you would want these values, these attributes to match your design situation, okay? So I gave it a grate that has a perimeter of 12 feet, so it's 3 by 3, and an area of 9 square feet. So those are the units you need for Flow2D. It's always feet or meters if you're in the metric system. A weir coefficient of 3, and then I also gave it a drop box area of 9. Otherwise, it would be 4 by 4. And then we'll go on to the outlet node. So that is basically the pump outlet. Whoops, I did the wrong one. Come on. If I do this wrong one more time. Okay, and I just called that P out. So every name has to be unique. That's important. And do not use the characters over 30 characters, because then it won't work. So don't use more than 30 characters, but it won't tell you it's not working. It'll just skip it. So that's important. Now, this is a junction, so that means it does not connect to the Flow2D surface. And I made okay, on this one, the only thing that I think is important is that this invert is higher than this invert. So in Flow2D, that's important. Now, on your swim setup, that's not as important, but on the Flow2D, that's important. Oh, it looks like I'm sorry, I'm just using this. I thought it looked good as a pump station, but it looks like it's actually a Wi-Fi tower. How funny. Okay, back on. Sorry, back on. Sorry, I got off a little sidetracked there. So invert elevation is just the grid element invert, and then I gave it a max depth of 1.5. That wasn't really important because I don't know the final design specs, so I just gave it that. And then doesn't need any of this because it's a junction. All right, let's take a look at the storage units. This is the pretreatment tank. The one that the client was interested in was called an Aquaswirl, and it has a maximum depth of 26 feet, and it has a invert elevation of 1205, which, if you remember, it needs enough of an area down here for the sedimentation, and then it needs to be high enough for the clean out. And then the offsets of these conduits are important. They need to be like connected to the protective works of this pump so that the inside water can float up to the top and the outside water or the heavy material can drop down to the bottom, but that doesn't like interfere with what's coming in on this side and what's leaving out on this side, which would be treated water, okay? Like taking out that debris. So that's why it's like higher and has a lower invert elevation, and it has to connect to the surface. And then it needs a tabular storage curve. So that is this guy right here, depth and area of a circle. And I just used a 7-foot diameter tank because there are some tank configurations online that do like the volume and the diameter of your tank versus the discharge that can be processed through that tank. All right. And then moving on to the wet well for the pump. Same thing. I went online and found the pump design specifications and based the sizing of the wet well to the flow through this pump system. And in this case, I think we're doing something like 10 CFS, but I think you can set this up. Actually, you can set up like 3 pumps here, and you can have them like 2 of them on and 2 of them or 1 of them off, and you can configure this with 3 pumps connected to these nodes. And I think that's okay. But I just did it using 1. So the pump unique name needs a curve to represent the flow, and it needs a status on, off. That could be on or off. And then that's your startup depth, and that's your shutoff depth. And that comes from this diagram right here. And then we have the conduits. So conduit number 1, remember the offsets are important. So it gets a length. That's just the length just comes from making that line. That's pre-filled. And then roughness, you can edit. It's set to 0.01 as by default. Inlet offset, outlet offset doesn't need, these two are not needed, and it doesn't have a flap gate. And it's just a gravity feed. I didn't give it entry and exit loss configurations, but if you want, you could give those entry loss coefficients like per the however that is configured in your in your Dropbox. And then your circular geometry and a maximum depth of 1.5, which was probably a little bit of overkill, but honestly, we want to feed those pumps, you know, as much water as they can take, and let the wet well, you know, or let the pre-treatment tank and the wet well define how much water they can hold and how much water they can process. So that's why these are kind of oversized. Then the next one, same thing here, 7 and 11 are the offsets, and we'll see the profile of this in a second. And then the final one does not have offsets, but you can see it's got its depth and everything, and everything's the same. And then finally, the pump. Wait, no, we already did the pump. Okay, no, sorry, I meant the pump curve. So on the pump curve, let's change over to the storm drain editor, and you can see we got our P curve 001. And then this, now you can use either this, depending on the specs of your setup, you might have the discharge based on the volume of the wet well rather than the depth of the water inside the wet well. So you can do this based on a volume. Type 1 is a volume versus flow, or type 4 is a depth versus flow, and they're variable. And so you're going to use either one of those. And then let's go ahead and grab that. If we click on that, it'll load the table, and the pump curve is really simple. But again, this would be per the specifications of the pump that you're deploying, okay? So this might be a little overly simplified. And pumps can also have things like rules and controls. And I haven't set any of those up yet, so we probably need to explore that a little more to determine some of the rules on these pumps and how they control the pumps. So that might be like a more advanced topic. Now let's take a look at this guy. And so this is exact same inlet, exact same outfall configuration, but let's take a look at the difference in the pump. Well, and the same pump. The pumps has the exact same configuration too. The difference is because it doesn't have that wet well, I just set it to start up at 5 feet and shut off at 3 feet, but this is the bad configuration. It's not going to work anyway. So let's do this. Let's switch gears and look at the results. So I ran this in pump test number 4, and so now if we switch over to the results tool, we can see that, and I'm just going to do the lines. So this is our conduit for our pump, and you can see that it gets up to 10 CFS and stays on 10 steady for the duration of the simulation. And we'll show you the basin filling in just a minute. And this one is the hydraulic pump, a simple pump, never turned on because the water surface elevation never exceeded 1224 or whatever it is up here. This one, hydraulic structure, simple pump, turned on, but didn't stay on because the depth in the basin got below 1 foot. So that might be a bit of a problem, you know, if you're trying to use a hydraulic structure for your pump, you might have to be more careful how you configure that rating table. And then this one also is going to show 0 discharge because this one is also badly configured. So now let's take a look at the profile. So the way that we do that is we go to the storm drain, and it's set to iBasin in, which is this one. So to set that, you just do this, and then you go start node, and then same thing down here except end node, and then you can plot your profile. Oops. Okay, and then you can see here that this is the profile of our system. So our invert elevation is 1211, rim elevation 1215, then our conduit, and then that would be that offset per the standards of the treatment tank, and then the offset per the standards of the, just got to get that water to that gravity feed, get that to the wet well. Um, and then the pumps, of course, are inside the wet well, so it pumps it from that up to the outlet works, and then the outlet works is just a conduit taking it down to the outfall. Now, let's see, what else should we do? I guess that's it. That's the profile. Let's see, can we animate that profile? So if we want to animate the profile, I think we need this tool right here, which doesn't like this window. And then we want to do refresh. And yeah, there we go. So you can see that filling up. You can see that basin filling up. And the basin doesn't really get much above 1215, except when the full big model is going, then it does. It gets up a little bit higher. And you can see that's the water surface elevation on the downstream side. And more importantly, you need to make sure that everything is exchanging to this side. So we should have, because two of these are working, we should have 26 CFS in this outfall, or sorry, excuse me, in this hydraulic structure. So I'm going to plot that hydraulic structure, and I'm going to turn on the inspect values, and you see that we do indeed get up to 26 CFS. So that includes the discharge of this one, the discharge of this one, and the discharge through here. So that, and why is that important? Okay, so this is very important. If this final conduit that's connected to this outfall doesn't have a positive slope, it might actually act like a sink and actually take water away from the surface right here. So instead of getting 10 CFS, you'll get 10 CFS removed. So that's why this always has to have a mildly positive slope, even if it's a bubble up. You don't want to have that be a negative slope. And that's kind of a Flow2D quirk. That's just a Flow2D thing. You can't have a negative slope connected to an outfall, between a node and an outfall of a conduit. Which maybe, now I don't think that's why this one doesn't work, but I suppose it could be. And that is basically the end of the simulation. So I'll go ahead and shut this down right here.